Well, thanks for having me again. I put together a sort of small presentation on solving business problems with OpenSIPS. A problem I've had to solve quite a lot in the past few years is, or at least cost routing in various and many guises. So I thought we've had to come up with quite creative solutions. Actually, just been hearing a bit sort of there about how we can achieve some of these things with OpenSIPS. So this talk really, the aim is to kind of go through what a typical business's idea of least cost routing may be, and just some of the sort of clever or creative things you could do with the OpenSIPS routing scripts to achieve your goals. Just really to demonstrate just how flexible OpenSIPS is and how we can really allow you to think outside the box should you want to or need to. My name's Peter Kelly. My company is called Sourcevox, sort of voice over IP and OpenSIPS software development consultancy based in the UK. You may have heard of some of our larger customers, Local Phone, Internet Retail, ITSP, they have over 1 million users, and Voxby is a wholesale termination company. We also work with a CLEC here in the US called Magic Telecom. Most of our challenges have come from these days. We use OpenSIPS, Asterisk, Rescript, RabbitMQ, Redis, Hadoop, Homer, and Sendoma, kind of have brought all these various open source applications into the mix at various points to kind of fix problems and to resolve problems whenever needed to, and to kind of, put things in place where they're needed. So, the title of the presentation is Solving Business Problems with OpenSIPS. So I guess the first question is, what is a business problem? I've spent the last 13 years working with businesses who want to solve problems using open source software, so I thought I should try and answer the question myself. So I thought for a few sections I came up with this as a definition of a business problem, which is something that must be solved in order for the business to move forwards. And I thought I'd also have a quick search on the internet to see whether there was a more formal definition of a business problem. And the one that the internet came up with was a perceived gap between the existing state and the desired state. So I guess both definitions say we want to get from here to here, and we need to solve how to get from here to here. I thought it's also worth mentioning it's not necessarily what the developers in a business want to write, and it's also not necessarily what a third-party software company has written and would like for business to conform to. Because I've been in sort of both these situations many times where you have to kind of get developers to kind of just solve the problem in hand rather than using the latest and coolest technology, and vice versa, trying to talk businesses into the fact that they don't need to buy SAP off the shelf when they can just quickly and easily solve the problem themselves with their own development resource. So I think it's important to keep this thing in mind. The second part of the title is least cost routing, and what is least cost routing? So the Wikipedia definition is the process of selecting the path of outbound communication traffic based on cost, which I suppose is accurate. And the businesses that I work with, their definition is usually route the call to the cheapest carrier, please. So in this scenario, in the example I'm going to work with today, I'm going to work with the definition of route the call to the cheapest carrier, please. So here's a typical example that a company may have. They are in the business of routing calls internationally. A very simple scenario we have here is that this company would route calls to UK Mobile 447. For the fraud people amongst us, I know that's not the full range that you would use for UK Mobile, but for the purposes of this demonstration, 447 is UK Mobile. They can buy the call off British Telecom for 1 cent a minute, and they can buy the call of Vodafone for 2 cents a minute. Obviously, BT are the cheapest, so if we're doing least cost routing, then BT will get the call. Again, for the USA, Orlando, AT&T, Verizon, BT, AT&T being the cheapest. This is what the business has got in front of them. They want to call to the cheapest carrier. Now, it's easily solved using the OpenSIPS module dynamic routing. Here's a quick example of dynamic routing. Has everyone in the room used dynamic routing before? So some people haven't. So typically, you don't have to use MySQL, you could use Postgres. You would store a configuration that represents the slide a few slides back in your database. So you've got gateway ID 1 is British Telecom, 2 is Vodafone, 3 AT&T, and 4 is Verizon. You can configure that into your DR gateways table, and then you would very easily have a set of rules in the DR rules table. And what this is saying is that when you call 7 UK Mobile, choose gateway 1 first, which is BT, and the next gateway to choose is gateway 2, which is Vodafone. So we've represented our least cost routing scenario within the dynamic routing module here. Cheapest is BT, so that's 1. Next cheapest is Vodafone, so the second carrier. When the call is routing in OpenSIPS, typically what will happen is the number guard will start with 447, which is the prefix. There will be a piece of code in OpenSIPS. The do routing function will get called. In the background, OpenSIPS will give the first carrier from the list of carriers against that prefix. It will set a destination URI to that gateway, and the call will be sent to that gateway. So in this scenario, the call will be sent to BT. Really simple, 3-line code. Now, if BT rejects the call, you can use the dynamic routing module to then select the next carrier from the list of carriers. Again, simple one function call, use next gateway, and it will send the call to the next carrier. In this example, it will send the call to Vodafone. The call is sent to Vodafone. Now, so the call gets into Vodafone if BT fail the call. And we have one issue, really. And if the call has failed to BT, then we just blindly will send this call to Vodafone. And we don't really know whether we're going to make money on the call. OpenSIPS is just doing what it's told. It's routing the call to Vodafone. But as far as OpenSIPS knows, it may lose money. It doesn't know, it's just doing what it's told. So the obvious answer is you don't put loss-making carriers into the list of carriers. So if we're going to lose money with Vodafone, we wouldn't have Vodafone in there at all. OpenSIPS, we've got no knowledge of the sell price. So in order to make sure we don't put our loss-making carriers into OpenSIPS, we have some kind of external application that's comparing our sell prices with our cost prices, and where we're going to lose money on a call, we just don't put that carrier into OpenSIPS. Dead easy. And then we've solved the problem of least cost routing. If you use the dynamic routing module, the example that I've just shown had 2 prefixes, 447 and 1407. We can easily scale this up to 70,000 plus prefixes for full A to Z routing. The company's got 20 carriers. Each carrier sends them 1 rate sheet per week. So every time we get a rate sheet, which is 20 times per week, we run some little process externally from OpenSIPS, work out which carriers we're not going to lose money from, and we populate those into OpenSIPS. And we need to do that 20 times a week, because every time we get a rate sheet from a carrier, we need to rerun the process and redo the algorithm to make sure we're not going to lose money. But the problem is solved, and it's relatively straightforward. And it's all fine, because this company has only got 1 sell tariff. They're only selling the calls to their customers at 1 price. So we really need to be concerned about not losing money versus 1 price. Well, now the business has decided that it wants to have more sell tariffs. It wants to offer their customers more price points to enter into their network. They decided they want to have gold, silver and bronze. And as far as the business is concerned, they're still solving the same problem, which is the calls the cheapest carrier. to look at to make sure we don't lose money against when we're routing these calls. So there's a few solutions. We can use the groups feature of dynamic routing. Dynamic routing module allows you to have groups of prefixes. So you could have group number 1, which contains your bronze prefixes, group number 2, which contains your silver prefixes, and group number 3, which contains your gold prefixes. So you could have 3 lots of carriers to route to in your dynamic routing module. It means that we're loading the 70,000 prefixes in n times, in this case 3 times, because we've got 3 tariffs now. Which is fine, OpenSIPS will cover that, no problems. But it also means that when we get these carrier rate sheets in, and we get 20 of these a week, we've now got 3 lots of groups to update in dynamic routing. Instead of just doing it 20 times, we're now doing it 60 times. So we're basically increasing the amount of work that our external application needs to do. And I'm sure there can be some efficiencies put into the external application. But we're still increasing the amount of work it needs to do. There's also quality considerations now. Because the business wants to sell gold, bronze and silver, you typically expect bronze to be lower quality, silver to be better and gold to be better still. So whilst the external system is looking at which carriers to put into each level, it's now got to also know which carriers will fit into each quality level when it's creating these 3 groups to route to. But the question is it really efficient? And can the external application cope? The answer is probably it's not really efficient, and the external application probably can cope. But a much better solution is to make OpenSIPS do the work. So we've now got our new business problem. We've got 3 sell tariffs to deal with: bronze, silver, and gold. We want to take into account carrier qualities, and we still want to do least cost routing. We still want to move to the cheapest carrier that will give us our gold level of call quality without losing money. So this is what we're going to do. We can tell OpenSIPS about the sell tariffs. If OpenSIPS knows about the sell tariffs, OpenSIPS can then check for itself if the call is going to be loss-making. So that removes the need from the external application to keep looking at sell prices, cost prices every time we get a carrier rate sheet in, and it removes the need for the external application to do that comparison 20 times a week and then upload all these carriers into dynamic routing. Because OpenSIPS knows about the sell price now. We're also going to tell OpenSIPS about the carrier qualities. So again, we can make sure we select the right carrier for the sell tariff. And we'll still do least cost routing, but in a slightly more clever and slightly more interesting way than just 2 function calls. And OpenSIPS do the hard work. So stage 1 is to get the sell tariffs into OpenSIPS. In the previous slide, OpenSIPS had no awareness of the sell price. Now we could use the dynamic routing module for this. As I said, dynamic routing has got the ability to have many groups of prefixes, so we could just create groups for each of the cell prefixes. And just devil's advocate, I thought we could use a dial-upon module for this as well. Because the dial-upon module will let you take a key, and when given that key, retrieve a value. Now, the dial-upon module is not the module to use for this because the dynamic routing module is really good at taking a prefix and finding the longest match, which is what you want for routing calls. The dial-upon module doesn't do that, and you'd end up writing your own piece of code to get around the longest match in dial-upon. So dynamic routing is the right solution for this. So basically dynamic routing, and we've now got groups in dynamic routing. So we've got group 1, which is gold, and now we've got sell price is 5 cents a minute for 447, and 10 cents for 147. Silver, and we've got bronze. So we've got all our sell prices, and they're all represented in dynamic routing. And this is what the dynamic routing table will now look like. Group 1, 2 of those, group 2, 2 of those, and group 3, 2 of those. And you'll notice that in the attributes column, which is the second column in from the right, we've now got the sell prices. So by doing this, we've let OpenSIPS know about the sell price and by putting it in the attributes column. And then we have a bit of code in OpenSIPS. And what OpenSIPS does by default with the dynamic routing module is when you call do routing here, it will automatically rewrite, it will work out which carrier to send a call to, and it will automatically rewrite the request URI, and it will automatically rewrite the destination URI, or it will do that implicitly. But we don't want to do that. We want to look up the sell price with this piece of code. We don't want to route a call anywhere. All we want to do is use the prefix matching ability of dynamic routing and pull out the attribute, which is the sell price. We don't want to route the call anywhere yet. We're just kind of using the module for each other benefits. And it just showed an example really of how you can do this in OpenSIPS scripting if you need to. We've saved the original request URI. At the top, we've called do routing. Our goal is to get the sell price. So basically, by calling do routing, OpenSIPS will have set a new request URI, which we don't want in this situation. So we'll basically reset it back to what it was, reset the destination URI, and our goal here is logged out at the bottom, which is to get the sell price, and the sell price has come out into an AVP variable, which is the role attributes. Does anyone have any questions about this so far? Does it kind of make sense? What's happening? So stage 2, stage 1's finished. At the very bottom, we logged out the fact we've got our sell price. So we managed to get our sell price as the call's flowing through OpenSIPS. Stage 2, we need to now get the carrier qualities into OpenSIPS. And as we said before, we've essentially now got 3 sets of carriers. Each cell product has kind of implicitly got its own set of carriers. For the cell pricing stuff, we stored 3 sets. We stored set 1, set 2, and set 3. But for the cost pricing for the carriers, we're saying, well, why store 3 sets when we can only store 1? We've already got our common separated list of carriers in our routing. So what we can do is, and this is exactly the same as in one of the very first slides, we've got our list of carriers, our list of prefixes, sorry, in the dynamic routing module. So you've got 447, here we use BT first, Vodafone second in the gateway list. But this time, we've now put these attributes in the attributes column. And by using these attributes, we can give OpenSIPS some important information about what's going on when it routes this call. So just to zoom in on the attributes a little bit, you'll see that essentially a set of 3 sets. So here we have gateway 3, which is a 0th element in the which corresponds to gateway 3. That even bigger. Okay, it's the gateway ID, then we have the cost price, which is 1 cent, and we have the quality, which is gold. So what we're saying here is that if we have a gateway list of 3, 4, and 1, we're saying that gateway 3 has a cost price of 1 and is gold quality. Gateway 4 has a cost price of 2 cents and is bronze quality. Gateway 1 has a cost price of 3 cents and is also gold quality.
So what does it mean, gold?
It's an arbitrary measure of quality that I made up for the purposes of this presentation.
So are you referring to the voice quality, or?
I'm really referring to what this theoretical business would class as a gold product. Normally gold, in my mind, would be high voice quality, high ACD, and guaranteed CLI. Whereas silver would be good voice quality and not necessarily CLI, and bronze would be
what's CLI?
Caller line identification.
Oh, okay.
So, but what we're saying for the purposes of this example really is that gold is better quality, silver is not quite as good, and bronze is not quite as good.
So they go to different carriers? Is that how it translates to your router?
Yeah. So carrier 3 here, we're saying back a bit. So carrier 3, we're saying it's prefix 1407, carrier 3, we can consider to be a gold quality. However, carrier 4, it's a prefix 1407, will be only classed as a bronze quality. And then this is a kind of an example. The beauty of these attributes is that they're really, really easily readable by OpenSIPS. The format you can store them in, so colon separated strings, which are comma separated. You can use the string select function in OpenSIPS to extract them really easily in your routing script. So, as an example, if you select the 0th item in the list, you'll get 3.1g. If you select the first item, you'll get 4.2b. If you select the second item, you'll get 1.3g. So they've been stored in a format that's really easy for OpenSIPS to retrieve later on. Okay, so that was stage 2, get carrier qualities into OpenSIPS, which we've done with attributes. Stage 3, we still need to do least cost routing. We've got our sell prices in OpenSIPS, we've got our cost prices in OpenSIPS, and we've got our qualities in OpenSIPS. So all we need to do now with our least cost routing, instead of just saying choose the next gateway, we can actually do something clever with our least cost routing code. Basically what we're going to do is look at all the gateways as they get selected by OpenSIPS, compare cost price and sell price, compare quality, and discard any that don't fit, and route the calls to any carriers that do fit. Just as an overview, this is basically what the tables look like now. You've got your 3 cell groups, gold, silver and bronze, and your group ID 10, which is the cost group, which has got your cost price attributes. Just go with that one. All we need to do is write the code. It's been written but not tested. Now, this is the code flow that the code is going to try and represent. So the first thing we'll do is a sell price lookup, which I've demonstrated in the sell price lookup code a few slides ago. Once the OpenSIPS script's got the sell price, we'll then call the DROUTING function on the cost price group, which will get us our list of carriers that we can route the call to. Once we've got that list of carriers that we can route the call to, we select the next carrier and we say, is the sell price greater than the cost price? If it's not, then we go and select the next carrier. So we've thrown away the first carrier basically because they don't match what we want to use to set the call. If the next carrier succeeds, if the sell is greater than the cost price, then we can go with yes, and we'll try and do a quality match. If the quality of the carrier doesn't match, then we'll go and select the next carrier. So basically we keep iterating through the carriers until we find the carrier where the sell is greater than the cost and the quality is the desired quality. And when we get that, we'll route the call and away we go. So this is the logic for our new least cost routing scenario. And this is what the code could look like in a very simplified format. At the very top, you've got your extraction and sell pricing, which is the code from a few slides ago that I showed. Then we call DROUTING, which gives us our first carrier. And what happens when you call DROUTING is OpenSIPS gets that list of carriers from the table, and it holds that list in AVP, which is a type of variable in OpenSIPS. And essentially that variable is an array, so if there's 3 carriers, there'll be a 0th element, a first element, and a second element. And it loads the information from the 0th element into its routing system. So it'll set the destination URI, it'll set the request URI. Now in the very, very first example, once we've done DROUTING, we just routed the call out to B2. But we don't want to do that this time. We've got our own new little function called RT-LCR, least cost routing. And what we'll do is we'll use the fact that OpenSIPS goes iteratively through this essentially an array of carriers, and we can do our comparison. So use a while loop. We can pull out the attributes using the string.select function. So our LCR LCR count first is 0, so we pull out the 0th list of attributes. Then using that 0th list of attributes, we compare cost and sell, compare quality, sell quality, and if they don't match, then we call the useNext gateway function. What this does is makes OpenSIPS move on to the first element in the array that the gateway is going to route to. And again, we've mirrored what OpenSIPS is doing. OpenSIPS is doing its thing here. We've increased our LCR count to 1. Then when the while loop gets executed again, we pull up the attributes that correspond to the first carrier as opposed to the 0th carrier. So basically we're comparing like with like. And eventually we'll get to a situation where we'll get to a carrier that we want to use to send the call. The route LCR will have succeeded and the call will route. So this is a really simple, really simplified piece of code that will fit on one piece of page. It kind of shows how you can use all the information that you put into the dynamic routing module, and kind of you can iterate through it. You can use the dynamic routing module to let it self-iterate through its carriers, and you can mirror it with your iterations, and you can really do some quite clever stuff on the fly. Does anyone have any questions about this?
Yeah, presumably you've got another layer on top of wrapper around this for the failed. If you have multiple gateways that actually are acceptable, the first one fails.
That's very good question. I'd actually forgotten about this one. But yeah, if the call should fail, you can have a failure route. And you fill your failure route and you do normal checks. Obviously, if the call is busy or engaged, you don't want to try a new carrier. You just want to reject the call back on the stream. However, if it's a rejection from the carrier, 503 or 500, then the beauty of OpenSIPS is that when you get into this failure route, even though your SIP packet has gone out and you've received your response back with 500 or 503, when the script fires up again to handle this failure route, all your variables will be there in the state they were in when the call left the platform. So, to go back one slide, we have our LCR count variable. For example, the LCR count was set at 1 because we discarded the first carrier, so we moved on to the second carrier. The second carrier sent the call to this second carrier, rejected the call, but all we do here is call route to LCR again, and we're still at LCR count 1. OpenSIPS' internal counter will still be the last carrier we routed to, so we can basically just continue our while loop where we left off. And that's a really neat feature of OpenSIPS.
So if I see that, what will happen? If you're a silver customer, you might get golden routes.
Yeah, I mean that's really the logic I've left out of this script.
Okay.
The kind of, I guess you could say that if you want gold, if you want bronze, then you're happy with a gold, and a silver or a bronze. You can kind of cascade it. But I mean, that's the kind of quality you can put in there.
No, I was just
Yeah.
It's a very clever way.
Yeah. And yeah, we talked about this really interesting thing we've kind of done around this scenario as well. Yeah, so I guess really, as an overview, we're using dynamic routing. So we're using the log prefix matching that OpenSIPS does. We're using the gateway selection that OpenSIPS does. We're using the fact that you can have the failure route and use the next gateway and all the cool things with the dynamic routing module. But we're also harnessing the powers of the OpenSIPS scripting language. And we're wrapping that around our use of the dynamic routing module. So we're using while loops. We're using essentially function calls that call routes in OpenSIPS, and you can recursively call routes in OpenSIPS. So you can call a route and the route can call itself until the conditions match. That works really well. So we use counters, we're iterating through arrays or sets. And the sort of main thing for me is that we're taking a piece of software which has got a list of modules, and we've got a real business situation, and we're able to use scripting stuff to apply real business logic to a SIP call as it's routed. This all happens in real time. a basic system in place for least cost routing. Takes into account business scenarios, supports multiple cell tariffs. We've only got 3 cell tariffs at the moment. There's no reason why we would have 4, 5, 6 or 7. In the original example I gave, if we'd have had 4, 5, 6 or 7 cell tariffs, you'd have had to have 4, 5, 6, 7 times 70,000 prefixes. Then you'd have to have an external application comparing what we're selling at with what we're costing at and constantly doing all these updates. And that really does get unscalable. And the way that this is done with the attributes is you can quite easily modify it to handle more complex scenarios. So, I mean, a few people mentioned quality. What does quality gold mean? Well, you don't have to have an all-encompassing quality called gold. You could have a bit mask, for example. So you have a flag within your bit mask that represents this carrier will give guaranteed CLI. You could have a flag which represents this carrier is going to give you an ACD of more than 8 minutes for retail traffic. So you can get quite clever with it, and then you can then say with your cell tariff, so when a customer has a cell tariff, that customer could say to you, I want only route calls where you're going to give me guaranteed CLI. And you might not have a quality level that says guaranteed CLI, but you've got a flag out against the carrier. So basically just go through the big list of all your carriers, and when you get one that's got the flag set guaranteed CLI, then you route call. And you're not having to compartmentalise everything into these big lumps of this is gold, this is silver, this is bronze. Again, with dialer traffic, there's some carriers that are happy to accept dialer traffic to some prefixes. You may have some customers that have dialer traffic, and you may want to make sure that their traffic only goes to certain carriers for obvious reasons. And the fact that we're storing the sell prices means that we're doing sell price versus cost price lookup. You can give users custom prices. I know that when you go to some of the bigger carriers, if you've got high volumes with the big guys, you can ask for your own custom price from them, and they'll kind of turn around and give it to you immediately. But kind of using this kind of example here, this shows you where you can, if you're running OpenSIPS as a carrier, you could give that custom price to your customers. Because at the end of the day, all you need is a clever way to pick out the price that customer is going to get for a prefix. By using dynamic routing or dial pan, you can do that. And another example, you could even allow loss-making calls. I know that especially for retail traffic, if you're going to make a loss on a call, some people don't want to reject that traffic. They're prepared to accept a small loss, but they're only prepared to accept a 10% loss, for example. So you could basically build in a 10% loss allowance for certain routes, because you're comparing the sell and cost price constantly. You can allow for that 10% loss. The data size in OpenSIPS stays relatively static with all these scenarios. You've only got one set of prefixes for your cost price. You've just got your carrier attributes that kind of expand. The processing by the external systems is static. So you're only processing each carrier rate sheet once a week. You have 20 carrier rate sheets a week. You're not having to then process that carrier rate sheet for each cell tariff. You just process the whole thing once, stick it in OpenSIPS, and you're done. OpenSIPS with the rest of the work. As I've already explained, I think it makes it all way almost impossible in terms of data size. Does anyone else have any questions before I'm just going to go and outline a really complicated example on the next slide. So if anyone has any questions, I'll give them time.
How much overhead does it add to OpenSIPS?
Not much, hardly any. The system, this is a very simple system. It's quite a complex system that I manage, and we did the load testing for it, and it was scaling up to 25,000 call setups per second. Going through that full suite of logic, getting the sell price, getting the cost price, doing the comparison, doing the quality checks, failing carriers, leaving through select the next carriers. It doesn't seem to have much overhead at all.
Does it go to database every time?
No, it's all in memory. The way dynamic routing and most of the modules in OpenSIPS work is write the information to a database, and then you send a command to OpenSIPS to say reload that information in. OpenSIPS will load the information into memory space, and then it will flip over and make that a live set of data. So yeah, it's extremely fast. Nice one, okay, so to take this to fairly extreme, well, it might not be that extreme, but it might be. Here's an example. One of the problems we've had to solve is NPA and XX jurisdictional routing. Now, NPA and XX is is how you propose to the US domestic markets. The NPA is the first 3 digits in your number, so Orlando is 407, and the next 3 digits are the NXX. And your NPA and XX will essentially map to an exchange. And it's, the way the American market works is, I say my English understanding of it, is you have a set of jurisdictions. So if you're routing from an exchange to another exchange, and they happen to be classed as local to each other, then you will charge one price. If you are routing from an exchange which is in the same, what's known as a local area termination agreement, a LAT, then you can charge another price. If you're going within the same state or between 2 different LATs, it's another price. If you're going between two states, it's another price. And if you're going international, it's another price. And if you're a carrier in the US, you are governed by the either federal telecommunication taxes or laws. If you're sending calls interstate, and within a state, you're kind of governed by the state level laws. So if you're going to be a competitive carrier within the US, you have to know about all these jurisdictions. You have to know how much you are going to be charged to send these calls, and you also have to know how much you are going to charge to terminate these calls if you own numbers. And we have to put together a really complicated, well, we have to put together a really big example of what I've just shown you with the American market. And there's 5 jurisdictions. There are 900,000 plus prefixes for a full NP and XX list. So you essentially look at 5 billion prefixes in OpenSIPS. In order to identify the jurisdiction, you have to understand whether the numbers are reported. You also have to understand which exchange the call is going to, which involves an LRN dip. You have to basically go away and say which number will this number terminate to. So there's quite a lot of things you have to do before you can make a decision about which jurisdiction the call falls in. And once you've made a decision about the jurisdiction, you have to do some routing against the jurisdiction. So we just solved the whole thing in OpenSIPS. Do the LR index in OpenSIPS, the carriers that will route to these jurisdictions with all the sell prices and cost prices. And essentially just a great big jumped up version of what I've just shown you. Was created to do quite accurate NPA and XX routing for US domestic. Now, I'm not sure how accurate US routing normally is, but I kind of get the impression that the incumbent carriers don't necessarily do real-time lookups as calls are routed. Sort of judging on bills that we had from Verizon. So I think this is quite forward-thinking, or at least what the company was asking for was quite forward-thinking, and we managed to achieve it. So we kind of got this highly accurate way of routing the call domestically. So that's it really. So I think I've covered most of these. Conclusion: it's possible to solve great problems if you explore outside the static modules. The scripting language is really what allows you to do it. You can basically just write anything you want in the scripting language and just work. Make OpenSIPS perform your business logic for you. It's definitely more efficient than using external systems. Any questions? No? That makes sense?
Good to hear. I have something to add.
You said questions.
Yeah, it's kind of a question or a note, whatever. There is a typical thing. You had the example of the failover
Yes.
in failure routes, and it's a typical mistake found in different kind of config files where the timeout is mishandled. In terms of you have to completely differently handle it if it's a locally generated timeout versus an received timeout. By timeout, I mean a 408 reply. For example, if you receive the 408 timeout from the gateway, then you should not consider it a gateway failure. It's a cold failure, and that's it, end of story. But if it's a locally generated 408, that means the gateway actually didn't answer at all, and you should consider it as a gateway failover so you can continue the dynamic routing. Because quite often the mistake is whatever negative reply comes from the gateway, people consider them negative, so you have a case for gateway failover. And
So in this, so here, you say that if it was
Yeah.
a 408, then maybe deal with this like
yeah,
this.
I saw there was a guy implementing the system, and he called me through the system, on the mobile phone, and first I reject the call, and he was trying calling me again and again and again via different gateway just because I did a busy 408, and so on. So it's quite a common mistake to, not to handle differently what's a call failure and what's a gateway failure.
Another one I've seen is some handsets will return a 603 or a 600 class response when they've got their phone set.
Yeah.
Asus returns 603 when you do a hangout.
Which I think that because the RFC, that means do not try any other gateways, do not try and complete this call any other way, do not reroute to voicemail. And I've had some fun and games with handling that before in failures.
Well, in my opinion, anyhow, the 600 class reply is a bit fuzzy, like what exactly it wants to mean, what's the meaning of it, like a global failure. I mean, how a single point can figure out if it's a global failure or not.
Yeah, how can one endpoint say, do not send to voicemail, do not try?
Yeah, I mean, it's not up to the device or something like
Probably
that.
more like, don't send it to my competitor.
Yeah.
Theoretically, yes.
I think there's
Yeah,
another
that's why we have, because by default, RFC says, okay, don't do any kind of serial porting anymore if you receive a 600 plus reply. But because there are so many broken devices actually sending reply, including like a busy, sending a 600 reply for a busy, we had to add this disable 600 blah blah into OpenSIPS just to be able to force continue follow hunting if you receive a 600 plus reply. But yeah, that's the difference between RFC and the real world.
There are actually 3 different 408 messages you can get. One is that you just don't get anything. The other one is that you get 100 or 180 ringing, but it times out. The other one is that the carrier sends you 408.
So there are 3.
There's 3.
Yeah, yeah, that's true. Yes, I mean you can have an internal 408, but with or without any provisional reply.
That's why we have the function T-local reply all.
Yeah. Because if you don't get any, if you get a 180 ringing or 100, then that's no answer, right? It's not a
Yeah,
failure.
it should probably, you as a proxy have a shorter timeout rather than the gateway, so it's still a call failure.
Yeah, we do it, we set it, the timeout to 2-3 seconds for the initial, for the provisional response. Plus we interact, we actually, it's the stack thing where we've got the B2Bs. We actually let the B2B set a flag, set a header flag to tell us whether, for instance, we're getting a 503 from downstream or whether if the header's not there, then it's obviously the B2B bot. And we do the same thing with the timeouts where the T-local reply or whatever it is. Yeah,
Yeah, the tricky part is when you have a chain of entities, like you have your proxy, then you have your back-to-back or whatever, then you have maybe the gateway and so on, is to decide, okay, who should be entitled of triggering the actual timeout on the call, like who has the shortest timeout, who controls the timeout when it comes to ringing. Because otherwise you can have triggering on timeout on all entities, and it's okay, you have to figure out exactly what's the meaning, if it's failure somewhere, or if it's a simple no answer, and so on and so on.
The distinction we figured out works is that we say if it's local, anywhere in the stack, the response is going to be really quick. And everything, so we basically assume if we don't get an answer within 2 seconds, then it's external, which is, it's a heuristic.
But it works.
Yeah, the real world.
I have to say, your solution is pretty clever. I was wondering, have your customer asked you to include some kind of punishment to some routes that are not working well?
What, sorry?
To include some kind of punishment to a specific route or of a specific carrier that is not doing well.
That is not doing well.
Yeah.
Like a penalty.
Yeah, you mean like an ASR or an ACD is below the threshold. You mean so for example, if a carrier is supposed to be gold, but they are delivering low call quality,
Or it's failing in sometimes, and you have to just get rid of it
they just
for a
get-
specific route.
Yeah, so there's obviously you need an external application somewhere that pushes all the routes into OpenSIPS, and that external application will typically also have information about core quality stats. And if people have been testing routes, if customers have complained about routes, then a carrier will be removed from the list. Yeah. Or the quality can be lowered. Yeah.
Essentially, you could use like an AVP DB, line that says, if you failed, throw something in the database that designates that there was a failure for this specific prefix, and then the script that runs in the background picks that up and says, okay, well, based on what I've got now, I'm degrading gold to silver for this specific route on this specific carrier.
Because really, it's up to you to decide whether you think a carrier is gold, silver, or bronze. I mean, a carrier may come to you and say, I'm gold, but it's really your customers that you care about. So you're the one that says, no, actually, you're not gold, you're silver. And actually, for this prefix, you're bronze. And actually, for this prefix, you're nothing.
Actually, every carrier is a gold carrier at the starter, but you have to measure and decide.
Just out of curiosity.
White routes and gray routes. Gray routes are clearly not.
Exactly.
Gray routes are not like top of the level.
Yeah, and some carriers may offer a call to one route, but it might British Telecom might be offering you a route to Australia, but it won't be very good, probably. So you might class them as gold for the UK, and not even in your routing for Australia. But I've seen major, large carriers also throw grey routes into regular routing as well, so I think you've got to be on top of it.
Hello, China.
Or you can, starting with 2.1, you can use the quality-based routing, which is doing exactly this kind of thing. It's detecting based on the signaling what's the quality of the calls, like all the combination between routes and gateways. So it checks not generically the gateway, but the gateway for a specific destination, according to your routing information. And then it can disable it. Let's say if it finds out that the quality is below some threshold that you set, then the module can automatically disable that the routing to that gateway for that destination. So try the next one available. So you can do that with the quality-based routing module.
Just out of curiosity, so working off of the scenario that we just talked about, so let's say that you've got something in the background that's running and it's updating all this stuff in the DB. How much of a penalty or how much do you get hurt doing those reloads on a consistent basis? Like, can you continually just do them like every 5 minutes, even if you've got 900,000 records in your table?
Yep. The penalty is the amount of time it takes you to read the data in from the database. So if you're reading 5 million rows, you're not going to read them in a few seconds. You're
Right.
15 minutes. So the penalty is you've got so many rows that you've got.
But while it's updating, you're not suffering any penalty of using the DR routing.
OpenSIPS has already got the copy of the routing tables in memory, and as it's loading in, it's loading them into another copy of memory. Then when it's creating that new copy, it will just kind of atomically flip them around.
Okay.
So you have only the PV penalty.
You need to make
like
sure
the
you've
load.
always got.
So it'll use the current one until it's done loading the new one,
Yeah.
and then, okay.
Which means if you've got a large set of data, large dial plan, large dynamic routing, you have to make sure that you've got enough memory allocated to OpenSIPS to store 2 copies of your data. And then if you want to reload dial plan and dynamic routing at the same time, 4 copies.
Right.
Okay. I've never thought about it, but is there a way, is there like I've never seen it, is there a revert? Because I mean, if you spend 15 minutes waiting for something to load and you discover, oh shit, and you have to wait another 15 minutes to reload the previous one, is there a way you can?
No, you cannot do undo because once the new set is loaded and active, becomes active,
Yeah.
the previous one is discarded from memory.
But wouldn't it be a nice idea then to have like a delay on removing the old set until so that you can actually go oops and ask it to revert?
Or just even have something to actually commit rather than, so load and then commit.
Load in a different route.
Yeah, but
And then
when
you
commit,
flip the customer to a different route.
That, he's
Yeah.
got it right there too.
So you,
And even nicer with the
same.
sometimes the group it's difficult because you have like group 1 is for that, 2 is for that, and you have to change in your script. Now we use group number 1 or now group number 2.
I have my file for customers. Each,
Yeah,
each
right now
customer has a specific.
you can use the partitions for that. So you have more partitions in memory. Like that's the safe one,
Yeah.
and that's let's say a trial one. I load it, test it, and whenever I want, I simply switch to a different partition of data. So that was the idea with partitioning data in all these modules. So if you have multiple instances, full flavored instances, I mean with groups, with whatever it takes, so you have the full copy over there, and you can decide from the script level which one you want to use. So you can have one of the safety net all the time over there, and try one, and using some global variables, you can just switch which one you want to use at the script level. And that's
So
it.
the revert basically would solve the problem in the one issue and not the two, right?
It's not a revert. It's you will say, okay, it's more like a default. You say you have to.
I'm sorry, I'm not saying there'd be a revert in the two. I'm saying if you were to do a revert, that would it's only necessary in the one.
Yeah.
There.
Yeah.
It's partially.
So you can, let's say, change a routing flag via management interface that you say, okay, go back and use the partition with the data that I know for sure it's okay. And then you have time to fix whatever.
One question. Have you considered ordering the gateways in real time by cost?
that was considered, but guys who were writing the external stuff said they couldn't do it. So it was easy to let somebody else do it. I did think about it, we did think about it, but because it could already be ordered externally, we didn't really explore it much at all.
So what was the question?
Instead of having, obviously this relies on your gateways going in least cost order, so you still have to do some work to organise the carriers into customers. Whether we've considered just putting them in any order and doing the sorting, as we would call it.
Something like cost.
Yeah, it's probably possible, isn't it? We have to go through all the way every time and then cash it.
One of the things that I didn't actually, I was thinking to do this, but if I'm correct, in rerouting, we do not have a function that brings all gateways in a specific line. You have to iterate to use next gateway. Could we have the list complete? The complete list in a single command to order? Because I don't have access to the.
Okay, they are like it's already used multiple instances. You can print it, all the instances of that AVP with the AVP star, so you can get actually a list. This kind of problem, let's say, was solved in 2.1 when we added the quality-based routing, because actually quality-based routing is based on the dynamic routing with introducing a new algorithm for sorting the list of the gates we have for prefix, right? So right now the dynamic routing exports an API which can be used by another modules to sort with whatever algorithm based on the moon phase or whatever the list of the gateways, right? So then you can come up with, let's say, with a module that hooks on top of the dynamic routing, and you can dynamically sort based on cost, for example. Yeah.
So I think it's an interesting problem, because I think businesses, when people talk about least cost routing, there doesn't seem to be any definitive solution to least cost routing, despite it being one of the most talked about subjects in most enterprise people.
Well, when it comes to costs, there is nothing simple about it.
No,
Well, there's even one carrier that there is a 1% loading in there, because if they paid with the Amex, then they got the air miles. So even though that carrier was slightly more expensive, there was a weighting put in there to account for the air mile value. So it can be quite complicated.
we were talking about profit optimization route. Let's do that, something totally different when you have a gateway that has a finite capacity, and you have call centers trying to grab the whole thing, the whole capacity for them paying very low. There are some customers paying more,
So you want them to
you need to rate limit the call centers to allow the other calls. There's some interesting things also to do in this area.
We've done some interesting things using the dialogue module around that to allow the last 10 channels to be reserved.
Yeah, that's the idea. Reserve some channels for corporate customers, or call centers grabbing the whole relationship. Really nice things.
Good.